Let us discuss sieve analysis. As we know, sieve analysis is done for the grain size distribution of coarse grained soil. Sieve analysis is done according to the Indian Standard Code IS 460-1962 revised. For this test, we will take approximately 500 gram of soil. अब हम selected number of sieve लेंगे, उसको इस तरह से अरेंज करेंगे कि लार्जर सीव्स विल बी ऑन द टॉप, उसके बाद धीरे धीरे कम होते 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 फिर लास्ट में पैन होगा. अब जो हमने सॉइल लिया था उसको सबसे ऊपर वाले सीव पे रखेंगे. उसके बाद हम उसकी मैकेनिकल शेकिंग या बाय हैंड शेक करेंगे इस तरीके से पूरे सेट को. द अमाउंट ऑफ शेकिंग डिपेंड्स अपॉन द शेप एंड नंबर ऑफ पार्टिकल्स. शेकिंग से होगा क्या कि कुछ तो सॉइल हर सीव पे रिटेन कर जाएगा और कुछ पास कर जाएगा. अमाउंट ऑफ सॉइल रिटेन ऑन ईच सीव इज वेड to the nearest of 0.1 gram. On the basis of the total weight of the sample taken and the weight of soil retained on each sieve, the percentage of total weight of soil passing through each sieve, also called percent finer than, can be calculated as below. First of all, calculate the percentage retained on a particular sieve, and that will be equal to weight of the soil retained on that sieve divided by total weight of soil taken. Here it is 500 gram. Since it is percent, so multiplied by 100. After that, cumulative percentage retained is calculated, and that is equal to sum of the percentage retained on all sieve of larger sizes and the percentage retained on that particular sieve. After that, percentage finer than the sieve under reference is calculated, and that will be equal to 100% minus cumulative percentage retained. The result of a grain size analysis is usually represented in the form of a graph. Percent finer than as calculated is plotted on the ordinate using an arithmetic scale. The size of the soil particle in millimeter is plotted on the abscissa using logarithmic scale. जो ग्राफ बन के आता है यूजुअली इस शेप का होता है. इट लुक्स लाइक एस, दैट इज व्हाई इट इज कॉल्ड एस कर्व. इट इज ऑल्सो कॉल्ड ग्रेन साइज डिस्ट्रीब्यूशन कर्व और इन शॉर्ट GSD कर्व. फ्रॉम दिस कर्व D10, D30 and D60 are calculated. The diameter D10 corresponds to 10% of the sample finer in weight on the grain size distribution curve. The diameter D10 is also called the effective size. Similarly, D30 is grain diameter in millimeter corresponding to 30% finer than. D60 is grain diameter in millimeter corresponding to 60% finer than. Based on the value of D10, D30 and D60, we have some coefficients like coefficient of uniformity. The coefficient of uniformity Cu is a shape parameter and is defined as Cu is equal to D60 by D10. Another shape parameter that is often used is the coefficient of curvature Cc, and Cc is defined as D30 square divided by D10 into D60. Now we will define the well graded soil and poorly graded soil. A well graded soil has a good representation of grain sizes over a wide range of its gradation. On the other hand, a poorly graded soil has either an excess or a deficiency of certain particle size. Poorly graded soil has most of the particles about the same size. For a soil to be well graded, coefficient of curvature Cc must lie between 1 and 3. In addition to this, coefficient of uniformity Cu must be greater than 4 for gravel and greater than 6 for sand. Poorly graded soil is also called uniformly graded. A gap graded soil is the one in which some of the particle size are missing.